Hello class, Dr. Mike. Just want to go over a few things here about topic 9, display and hardware. So some hardware resources we could check into. So first off, let's talk about something real specific. That is the proc file system. Proc file system is actually a virtual file system. If we look at the files here, let's look at meminfo. We can see it's 0 byte size. But yet if I cat out meminfo, it's full of data. So the proc is actually reading the live kernel and all its settings in memory, as well as processes. You can see here, these are actual process numbers. Now I won't get into the process side, but there's information in proc you can actually harvest. So first off, let's talk about our first resource, and that is the CPU. There's the CPU info, and it will break out into the processor family, the speed, also the cores. Now, of course, this is a virtual machine in NetLab, so there's only one processor with one core available. But it can give information like what speed is running at. As we saw before too, there is meminfo too. Total memory, cache, swapped, more information you probably ever need to know about memory. Now, there's some stuff in here in proc that's not really user-friendly. Example, there is an uptime file here. If I cat uptime, okay, 950.53 and 889.86, so not too handy. If I run the uptime command, well, there you go. I have how long it's been up and the load averages, which we'll talk about here in a second too, and how many users are logged in. Been up for 16 minutes. So in any case, sometimes when you use stuff in proc, it's not going to be the easiest thing to look at. Uptime's a good example that CPU info and meminfo are pretty easy to look at. But there are, as you saw here with uptime command, there are commands that harvest this information and display it in a more user-friendly format. So LSCPU, LSCPU. Again, it's a nice way to basically get the information back from proc. So we can see the byte order, it's CPU mode. If it's a 64-bit, 32-bit, it's both in this case. So 64-bit CPU, and we have our speed in megahertz here. So no surprise, we also have a command to look at memory use. Now, it's called free. Here we get to total memory, use memory, and free memory. Also swap space use, which is pretty good to see. Swap space, again, is a part of physical disk that's set aside by the kernel as a temporary place to sort of hold stuff. And it's common for it to be used partially, but if you have high swap use, it could indicate a system issue. So, and it's going to depend upon the system itself. We had a system I used to work with that should not be swapping at all. If it was, it was usually indicative of a database issue. So we would write scripts to use free. We would grep out the swap line, use awk to get that column, and then we would evaluate that as an integer if it was above a certain threshold, like 1024. Then we would actually send an email using the system email to the support email. So as you can see, you can use this information in automated ways too. So free is a good way to look at memory use. Now, as we look further down here, let's look at our devices, our hardware resources themselves. So the first thing we're going to look at is actually our PCI bus. So we have LSPCI, PCI, and that will give us information about the different devices on our bus. Now again, we have a virtual machine here, so it's a little more thinned out than you would see on a real system. Now you can use LSPCI with a -V. So this LSPCI command has several levels of robustness. You can see here with 1V, which I did before, actually get information about the slot it's in, capabilities, the kernel driver in use. That's pretty good information right there when we look at driver usage. And of course I see access denied here too. We'll come back to that in a second. But I can do several levels of V. I can do 2 Vs. I get even more information. I could do 3 Vs. And I think 3 Vs is the deepest I can go. I get more information I probably ever need. Now about accessing these commands. Sometimes you want to run these things as root. And so you can see here, I am not root, I'm the user sysadmin, which don't be fooled by that. I'm not a system administrator, root is. So in this system, if I do su dash space, ask for the root password, netlab123, I have now root user. Some systems you might need to do sudo su dash, and then put in the password for the user you're sudoing as, in this case, sysadmin's password. So I think that's going to be the Ubuntu system will need that, but for Fedora here, I believe CentOS, we just do su dash. So now you can see I am root user, LSPCI, PCI mic, -V. Now capabilities are exposed. So, and device serial number is pretty good to know. That can be very handy. Again, this is a virtual machine, so we have some sort of the abstraction is going to be a little odd than actual physical hardware. So our other bus we want to look at is, of course, our USB bus. Now, there's nothing here to look at, so that's because this is a virtual machine, but it acts the same as the other command. We can do -V, and you get several levels of USB information. That could be handy when dealing with external devices that are plugging in and not working correctly. You can verify the USB sees it at least. So you run LSUSB before you plug in the device, run it again, you should be able to see the device show up. So a couple other things we'll look at here for system resources is, of course, disk use. So DF itself here gives us each file system and the percent used. Now, if you want the actual usage over percent, the actual kilobytes used or megabytes or gigabytes used, you get 1K blocks here, which you have to go into and put in the commas, and that's too much work. So df-h gives us a human readable. The -h gives us human readable, which I guess we can see 12 gig with 3.2 gig use. Much easier to look at and easier to read. So disk use, we covered that. Memory with free. And of course LSCPU for information. But let's look at overall use of the system. And that's our top command. Top is interactive, so you can see it's actually running live. It's split into two parts. I won't go into all the uses of top. Let's do Q to quit, and we'll break this down here. Now, the top part of top gives us information about CPU usage, memory usage, and swap usage. So again, in one place. And again, the bottom part is our processes and what's the most used process. In this case, top was one of the top used ones. How much memory is being used, how much CPU percentage is being used also. Now, load averages are really actually very handy. I think we have the 1 minute, the 5 minute, and 15 minute average. Now, of course, 1 is spiked out. Even over one, it can actually really be heavily used. The lower the number, the less usage. What you have though is if you have a high 1 minute but a low 15 minute, indicates a spike in usage. Whereas if you have a high 1 minute and a high 5 minute and a high 15 minute, and all those increasingly getting higher, then you have a system that is going to be overloaded and probably have some issues in it pretty soon. So load averages will help you to determine the history of load, not just is it a spike, but is it a gradual increase over time. Top's great though. It's a great way to look at information about your system. And this is very common to what you might see in Windows with your task manager. So the running process is listed as well as information about your system. So top is fantastic. I think I got most of the stuff here. Now we looked at top memory. I think we're good. So we'll come back and look at modules themselves and what those are in a second. So for now, that gives us the information we need about our system, and I'll see you in a little bit.